Hi there all, this is Q&A. And what types of datums are used in Ecdis? There are several types of datums used in Ecdis, and this we have to take in account. We have a horizontal datum. This is a reference system for specifying positions on the Earth's surface. It is associated with a particular reference spheroid and can differ in size, orientation, and relative position from other horizontal datums. For instance, the World Geodetic System 1984, or we call it WGS84. It is widely used horizontal datum. We also have a vertical datum. This refers to the water level that serves as a zero point for measuring depths and heights. It is crucial for determining tidal information and the clearance under the bridges. And there is a sounding datum. This is related to the depth measurements on nautical charts. It is the level below which the seafloor exists and is used to measure the depth of water bodies. It is important for navigators to understand these datums, as they affect the voyage plan and the accuracy of positions on charts. When using Ecdis, it's also essential to ensure that the positions obtained from satellite navigation systems like GPS are adjusted to the compatible with the chart datum. Once I read information that the United Kingdom Hydrographic Office estimates that as much as 20% of the Admiralty charts cannot be related to any known datum. In some cases, this can result in a difference in position of several miles. Also, we know the fact that the Earth is assumed to be spherical in shape for the purposes of sailing calculations and practical navigation. However, it is not actually a sphere, but is slightly extended at the equator. The diameter between the poles is approximately 23 miles shorter than the diameter at the equator. Traditionally, paper chart producers developed local horizontal and vertical datums to make the charts for a given region represent the real world as closely as possible. All INSEEs use WGS84 datum, which models the Earth as a sphere, so that GNSS positions may be plotted directly to the INSEE. The WGS84 datum is a spherical model based on an average diameter for the Earth, and therefore does not precisely reflect reality at every location. Using WGS84 for all INSEEs allows seamless coverage for the entire globe on one system by using the best fit datum. In addition, it is useful to know that most INSEEs have been reproduced from pre-existing paper charts, many of which were not produced using WGS84 datum. Converting paper charts from local best fit datum to the WGS84 best fit for the world datum is achieved by using a mathematical conversions formula for the position of each charted object. This means that plotting a GNSS derived WGS84 latitude-longitude position of the vessel on INSEE may be done directly by the Ecdis. However, transferring a position to a paper chart with the local datum without using conversion factor may result in a difference of hundreds of meters In many cases, all the paper chart use datums for which the relationship to WGS84 is not accurately known. Information concerning the differences between satellite-derived position and position on affected cells can be found using a cursor for peak report. At the same time, one of the advantages of ENCs over paper charts is their standardization. This means that units for position, depth, height, positional accuracy and distance will be the same on all ENCs. Horizontal datum is standardized to WGS84, but vertical datum and sounding datum are not standardized. Instead, elevations and soundings will equate to those used on the equivalent paper chart or source data. For example, many European ENC producers use mean sea level for vertical and sounding datum, while others use mean high water spring for vertical datum or lowest astronomical tide for sounding datum. WGS84 is a standard horizontal datum for GNSS use. Datum information is available via cursor peak and should be used during the planning phase to ensure that safe clearance calculations use the correct vertical datum. Another datum-related issue that must be considered at the planning stage is the existence of areas where horizontal datum is imprecise or not known. This means that despite the ENC being standardized to WGS84 datum, the GNSS-derived position may have an error. These areas must be identified and the use of visual and radar fixing incorporated into the plan to check the validity of the GNSS-derived position. Also, navigators must understand that GNSS receivers may be configured to supply the data to Ecdis in different types of datum. For that reason, Ecdis continuously provides the information about plotting position datum, and it is well visible at the Ecdis screen. Be aware that some Ecdis allows the navigator to select a different horizontal datum to WGS84. Doing so is dangerous when displaying an ENC, and in such cases, a check should be conducted to ensure that the horizontal datum in use is correct. So, as a summary for the above stated, every ENC must use the WGS84 horizontal datum, but each ENC can use a different vertical and sounding datum, and the height of tide must be added to the sounding datum, as each charted depth sounding is a reference to ENC sounding datum. The charted depths can be used directly from the Ecdis display. At the same time, when calculating vertical clearance, the difference between the sounding datum and the vertical datum must be determined. There are numerous vertical datums used by different hydrographic offices, so each ENC must be carefully interrogated when calculating clearances. A datum actually, as you understand, is a point, line or surface from which all measurements, either on the map or on the Earth, may be referenced. The datum now widely used for most navigation globally is a particular spheroid, and associated reference points define the world geodetic system. The latest version is being WGS84. In fact, defining a terrestrial reference frame is never-ending process because the Earth itself is continuously changing, in particular by tectonic plate movement. For instance, the subcontinent of Australia is moving northeastwards at about 7 centimeters per year. Also, as example, I want here to say that the Russian GLONASS satellite navigation system does not use the WGS84 datum. Instead, it uses a datum known as a PZ90, which is based on a different set of reference points. Because the points are different, the reference frame is not the same to the WGS84, and so slightly different latitude-longitude positions result for any fixed point. The need for a common framework is evident and has been met by the International Terrestrial Reference Frame, which is regularly redefined to take into account tectonic and other movements. Nowadays, both WGS84 and PZ90 are kept quite accurately aligned to the International Terrestrial Reference Frame, and for normal navigational work can be considered to be identical. Whilst local datums are still in use, most marine paper charts are now to WGS84 or to a datum where there is a known relationship. In the long crossover period, from traditional to satellite navigation techniques, the question of datums has been extremely important to the user and often confusing. Fortunately, the use of Ecdis with modern positioning systems is now beginning to eliminate these problems. Thanks that we are having Ecdis nowadays.